But
Andy.
so far, he hasn't hooked up his Hoover shoes.
Mute.
So, all right. So I decided a couple of years ago to make at least one of my instruments a little bit more streamlined and got into the CNC realm with Allied Blue 3. And Will did some design work for me on the electric bass, the Healer bass that I make. I'm doing a few different things on this instrument that were making it kind of difficult for me to kind of get things dialed in to do by hand. And Tom's drawings that he'll show you in a little bit will kind of clarify that end of things.
Yeah.
But basically, there's a pitch to the headstock, but it's got the scoop like a Fender.
Yeah.
Where the headstock and the fretboard transition into each other with the radius. So all the drawing went fine and the milling went fine, but they got really busy with Iris guitars. And so I decided after doing the class with Tom that we should, it might be better to collaborate that way.
Were you producing that cut by hand before?
Yes.
And what was your routine for producing that cut?
So I would first cut the back of the peg head and the back of the neck. So it was basically like you would see the transition that would be, and it was all drawn. So I would draw on the edge of the neck, or I had a template, I guess. I would trace that, do the back of the neck, and flatten the back of the peg head. And then I would put a board on the back of the peg head and feed that through my spindle sander with a fence.
Okay.
So it was like creating that back surface and then working on the front surface. And I get just to the point of like where I might want to glue my headstock on, my fretboard on.
Mm-hmm.
And I'd make sure everything else was lined up. I'd glue the fretboard on and leave that fence in place. And the next day come back in and do that.
And how long was it taking you to spindle sand that? That seems like a really rough amount or I'm guessing you're hogging it out with the bandsaw first, or
Yeah, totally. I'd get it like within an eighth of an inch on the bandsaw. So I was probably I go pretty slow with 80 grit, and so I was probably taking like 10 passes, in and out, adjustment. And
we also know like spindle sanders can be like they can be not the squarest, thing in the world, right?
Sure. So my fence, I've actually used it so much that it's like ever so slightly tapered. So it's not square, but it's square to the face of the spindle.
Okay. Cool.
So like I could just do this and I would have been fine. But like there was never going to be like, oh, I've got 4 bass necks over there. I've got 10 bass necks ready to go.
Or
because it's just exhausting.
I want to hire somebody to do this, and they've got to know every single little idiosyncrasy of the
correct.
Of the
so
moves.
I was trying to explain it and just getting like, oh geez, forget it. I'm just not even going to do it. And then in the meantime, I just started doing just a slanted peg head. Mm-hmm. I would scarf joint it or whatever, do a veneer on the face, just like Gibson, but like a shallow angle, like I do the majority of the rest of the instruments. But something about it just didn't feel right. It didn't feel vintage. It felt like it was like a compromise. So then in talking to Tom, it was sort of like, okay, I think Tom, you got a pretty good sense of what I needed to do pretty quickly. And it was just about how do you create the jigs that hold this thing in place to mill all the surfaces. And that's really where it seemed to come together, and like, let's make these jigs that hold the neck in the three different positions that it needs, like pre fretboard, post fretboard, and so that also if I buy a machine, the jigs are mine and they come back to me and I can mill the necks myself because all of that work was done. Whereas with Allied, it was a little bit more like, we want to do the work, but we just can't seem to get to it, which was a difficult position to be in.
So I guess my question is Tom going to be the only one here not in a Healy guitar shirt?
I guess so.
Yeah,
Okay.
I need to rectify that.
I know. How much money are you spending on shirts that everybody I see is wearing a Healy shirt now?
Well,
Mama pajama.
they're all really good people.
And this thing is so comfortable. You're really like putting out a comfortable shirt too. Like this is really nice. And very flattering also. It's not like it doesn't cling to the belly like a lot of shirts that I have.
Good
Awesome.
comfort choices too.
Yeah. So anyway, Tom, I wanted to talk to you also a little bit about this. And I mean, we could look at all this stuff, but somebody comes to you with an idea like this. How are you figuring out like engineering on this? Because sure, there's like the CNC operation, but you've got engineering time in this. Are you just straight up billing hourly, or are you going, I like you, Trevor, I'm going to cut you some slack, or how is this going?
Trevor was very patient with me. So
Uh-huh.
Trevor definitely got a break on that. Like what Trevor just said, I don't necessarily want to just sit here and be like, I'm going to do everything for you. My goal, and this has kind of always been my goal in doing the CNC stuff, is like, I'll get you started and then let's get you doing this, which has kind of evolved into having this class now. So I could have done some kind of cowboy CNC stuff with Trevor's necks, but then at the end of the day, like what he was saying, then he'd be right back at square one when it came time to do it himself. So I spent the time finding a way to make these necks machinable, where all Trevor is going to have to do is put it on there, press go, it does it, and then glue on the fretboard, it does it. And one of the big things that I teach, like in any sort of CAD stuff, is like break things down into their smallest bite-sized piece. So a neck with a volute, with an angled peg head, with a scoop. So I can machine a neck very easily if the fretboard isn't glued onto it, because I can do the peg head face from a billet. I can do the truss rod slots from a billet. I can do carbon fiber slots from a billet. That's all really easy. And then when I flip it over, I can carve the back of the neck like normal. Now, in that case, I'm not able to drill tuner holes or cut out the peg head, but I could go make separate jigs that would do that. But in this case, because the fretboard was radiused as it went onto the neck, that is where the problem lied. And also the fact that the fretboard and the peg head face had to be machined at the same time. So when Trevor came to me, we actually started like talking about this. It was like really kind of late at night. And I actually have like a note in my notes that pops up when I was like, all right, these are my solutions for this. And I was kind of going back and forth with Trevor and kind of showing him rough drawings of things like that. And then as time went on, I said, okay, well, I can get this kind of close, but how can I get this dead nuts on? And I borrowed techniques that I used on other builders' stuff to do this. So primarily like Dion James's bridges, when I did those, I used some techniques from that. But the first thing that we ended up doing was we had to do a little redraw of the neck too. So Trevor had some changes that he wanted made.
Yeah, like the volute area, like we only did one. I think we only did two necks with Allied that came back, so I didn't get to do a revision on the volute. So it was just like it was kind of a small quick change that I did like right before they shipped, and then we never got to kind of follow up on it. And so what I really like to do is kind of have it's almost like the volute doesn't really flip up. It's just I mean, in this case, it flips up, but ultimately what it's doing is you're taking the back of the peg head and transitioning back to a flat surface that is parallel with the back of the neck. And it just flips up ever so slightly. Sometimes when I do this by hand, it just ends up being flat. It's just a transition that flattens and is like an eighth of an inch above the level of the back of the back of the neck. I've never seen that anywhere before, and I think it's a byproduct of a low angle on the peg head.
Yeah.
And it's just something that I slowly started to see as I was making these things. So this has a little bit.
Anybody else doing this style of peg head? You know?
Rob Raddick, he's a builder that I worked with at Sadowski. He does it on the guitar, but he's actually building very different guitars at the moment. He's probably it's one of those ideas that kind of happened simultaneously. We both left Sadowski. We both did other work on our own, and suddenly I saw a Raddick, and he had an angled peg head with a swoop into the neck, and I think I'd done 3 of them at that point, and we weren't in communication. It just simply was like we both kind of had this idea. I felt like it was kind of based on what Roger, like working with Roger and working on vintage instruments. So the reason why I wanted to do an angled peg head was because of like the 100 P bases that I've seen that come in and the headstock tip is twisted upwards. And the thickness of the headstock is based on what Roger did. He literally added about a 1/16 inch of mass to the peg head, and there's still plenty of tuner exposed to put your strings on. So it's just kind of combining those two ideas, like what's going to counteract the twist and pull from your bass strings, and it's creating a little bit of pitch. And I don't completely eliminate the need for what's it called, the string tree, but it's not 100% necessary.
Okay.
And I hate string trees. I just think they're dumb.
So do you ship with a string tree or no?
I do. But I built, I think, 3 that I didn't bother putting them on, and nobody mentioned it. It was sort of like 3 weeks later, you get this message like, hey, there's no string tree. It's like, do you need it? Well, I guess not. Do you want to see it? No. You know, just like wanted to know.
Cool. So Tom, what's that drawing that isn't in the 3rd dimension? Is that like just your sketch or
This guy? Or
no,
this
the one with the tuners in there.
So these 2 entities are actually what Trevor got from Will. So he drew the profile of the neck, kind of the volute shape, and where the truss rod would be in the heel shape. And this was his 3D model of that. And first thing I noticed was there was kind of a little bit of a gap here. So I was like, hey, I'm gonna like, is there a reason why this would be here? Like, is there something funky going on that I'm missing? Like, are you machining this area flat? And Trevor was like, no. So I ended up redrawing it and drew it to this. We moved the volute up, and then we also changed the height of the heel a little bit.
Mm-hmm.
And that also changed because there's an angle. These originally came with an angle in the heel. We took that out. So I took these drawings and then I modified them into another file. I also took like a side profile. I projected a line down onto this, so then I could see a 2D profile of all of my surfaces. And this was the start of kind of the jig making process.
So what?
Go ahead.
On the jig, before we get into the jig, can you talk about like when Trevor first told you about this, like what pinged off in your mind that this was going to be a challenging milling procedure?
Yeah, let me see. So a few notes on our meeting. This is from November. So these were like my initial thoughts. First off, I'm really liking the idea of making a vacuum jig to angle the tire neck for the face spec head machining. I have a model I am working on, but I need a bit more information on your end to move forward. This hurdle is figuring out a way to register the neck. And then this is just explaining that the CNC can only move up and down along the Z-axis. Drilling holes into an angled jig cause the part to typically be pushed forward or back. In this case, the part would be pushed forward. We could use a technique that Ben Kaler, came up with for the angled neck pockets. Basically, slots are machined into the jig rather than the holes that allow the part to stay on center while bumping the pins. While the bump pins are utilized to register the part. And clearly, I was in the middle of writing and I stopped.
Can you explain all that with kind of hand gestures and maybe like your finger as a CNC cutter? And
Yeah. So let me exit out of oh, is it gonna let me? Why can't I see the thing? Oh, here, it's down here. So when you have a CNC, unless you buy a really, really expensive one, they only move in 3 directions. They move up and down. So that would be one direction, I guess. So technically they move 6 directions: up and down, left and right, forward and back, in some combination of that. So if you have your peg head and you tilt it forward like this, the machine can only go up and down, right? So I can't go with an angled peg head and drill a hole that is perpendicular to the face of the peg head like we do on a regular guitar. And the same thing occurs for jigs. So if, we're talking about wanting to tilt the neck forward so that the peg head would be flat to the surface, but then I can't use locating pins in my jig because I'm going to have an angled surface. I'm going to have the machine that can only come down, straight down. And when I machine those holes into, say, the back of the neck, they are going to be straight. So it's going to push things forward. So Ben, when I was doing, because Dion James, he's an acoustic guitar builder out of Canada, he said, hey, well, you can't, because we're like trying to get the intonation just right on these bridges that we were making, because he does the turn, what people call the Turner tilt. So Rick Turner would machine his saddle slots at an angle. So when the top would flex, when the top would torque, the saddle would be more straight up and down to the body of the guitar. And obviously a saddle on an acoustic guitar, like you need to get that saddle in the right spot. So I was like pulling my hair out over this. And Ben said, all you have to do is you make slots in the jig that the pinholes that the pins can just sit in so they can slide forward and back, and then just make some registration pins that I could very easily model in Rhino that would allow me to slide the bridge back so that the 2 wings would make contact with the pins. So that idea made it onto the angled jig that I made for Trevor. So when I would machine the face of the billet and do the truss rod slot, the carbon fiber rods, and some locating pins for when I glued on the fretboard. Then I would flip it over onto another jig and I would make basically the silhouette of Trevor's neck. So it would have the flat part of the heel down into the heel transition, the flat part of the back of the neck up into the volute, and then up into the peg head. And so that would be the male portion that would then be accepted by the female portion of the jig. But I also drilled 4 holes outside of the profile of the neck that I could put metal pins into that would register on the jig. Now, since every single neck was machined to the same shape, I would have the machine cut it into a block before I started working it. I could bump the tip of the peg head, or what was the tip of the peg head, up against some pins to keep everything all hunky-dory when it came to registering everything. So making sure that the swoop of the peg head was where it needed to be, all the tuners were where they needed to be, and the shape of the peg head was cut out correctly. So I've seen other people, and I myself have done other techniques for machining the back of a peg head. Like I was doing Todd Lundberg's acoustic necks, and he does a Olsen thing. So they have a diamond volute, but then underlay goes around it. And I would suction down the face of his peg head to the machine to do all the machining for the back of that. And the neck, the barrel of the neck would be kind of sticking like this. But because we had to glue the fretboard on in order to get the swoop, I couldn't do that. So there was a whole lot of like, okay, I can do it this way, but how is it going to affect the rest of the process? Like, when do I need to glue things on, and at what point?
Yeah, and there was some discussion of like, okay, what do you want to receive? And I think this might be somewhere that we continue talking, is like, what if the swoop was put into the fretboard and I still align the 2 pieces and glue them up when they come to the shop, but it ended up being easier to work through it if you kind of took care of this time and got to work through it.
Yeah. So ultimately, what we ended up with was the other jigs were, and I can take you through the other processes that we went through as well, so you can see that.
I do want to see that.
I can't show you the cam because Rhino Cam doesn't work on Mac, but I certainly can show you the rest of the jigs. What do we got? Retro drill. Oh, the other tricky thing was that the fretboards were already machined when I got them. So I had to retrofit the fretboards to work so that we could use those fretboards that Trevor had already had machined. So
yeah, it was like we'd gotten to a point with Allied where the fretboards were completed, and they sent me stuff to send to Tom, like fretboards, wood, graphite, truss rods, drawings.
Yeah. So here is the first jig in the process. It's just a flat jig with some vacuum channels built into it. And this was so I could go and machine the billet to the size that I needed the billet to be. And also I could flip it over, and then I could also machine the truss rod slot and all of that kind of stuff. And that is in another file as well. Let me see if I could find that other file. Fretboard retro, that's the angle guy. Okay. So the same jig was used for this step. So after the truss rod slot got machined, let me see if I can get my layers going. So again, there's that same jig. And here is the step for actually machining the truss rod slot. You can see we have the carbon fiber, we have the truss rod in there. The machine would run up and down, machine this stuff. And then this is just a fretboard retrofit jig. So you can drill some holes in the bottom of the fretboard that would coincide with the holes that were being machined into the neck. And then this would be useful for gluing on the fretboard. In other cases where I'm machining necks, that jig is very useful because I can use that to mount it onto the jig. After all that was done, that's where this other jig came in.
We get a little closer.
Yeah.
Sorry, you're probably fixing to do that.
So this was the rough shape that I'm talking about that I was machining into. And let me turn off the table so it gets a little less messy. So this is the exact profile of the neck. Here is the neck, the actual model of the neck. And you can see we have the rough shape. Let me do this from the front view or the side view. To its absolutes. And you'll see that I left the peg head face flat because that I wanted to leave material there to machine away after I glued on the fretboard. But I projected a line down onto the shape of the neck and then created this section. Now here is where those pinholes that I was talking about are. So there's 4 of them. So the machine would come in with a ball end mill. I think I roughed it first with a flat end mill, a 1/2-inch flat end mill, and then I used a 5/8 ball end mill to machine this shape in, and then a 1/8-inch bit would come in and drill these 2 holes. Now these 2 holes would go after the truss rod slot, or the truss rod was installed, and the carbon fiber rods. The fretboard would be glued on. And then we would come over to the behemoth jig. This thing weighs like probably 60 pounds. And I made it all out of high density polyethylene that I epoxied together. And high density polyethylene does not like to stick to anything, and nothing can stick to it. So that was kind of a challenge. I ended up using, StuMac made a tool called a toothing iron that was never available to the public. And they made it for Martin, and you can use it for like roughing up edges for like mechanical bonds for things. And we used them, but they sent them to like Brian, Dan, Doug, all different people. So I used that to do the mechanical bond. Then I was like, oh wait, I can probably just use the time saver. So I did use the time saver too. I had a few of these jigs blow up, and then finally I realized that I was not using enough epoxy. So I think I ended up, it was Ben and we used like eight pumps of West Systems epoxy to laminate all the pieces together. It was very stressful, it was very messy, but it worked in the end.
And this sort of comes to the part of where Tom is like, I don't hear from him for 3 days. I'm like, hey man, how'd it go? And
Uh-huh.
Yep.
You don't even don't talk to me, right? Not in like the nicest possible way. I will work through this. Do not worry about it.
It was,
but this is hard, and when so Tom was saying yes, being very generous with time, but your initial conversation with me was like, we charge X amount for the jigs, right?
yep.
So it's like, if you're going to do 3 jigs, you're in for X amount of money to begin with. And I said, yes.
Yeah.
So in retrospect, we might have gotten further along in the design, and you might have had a different quote, and you might have said, I see this as potentially being twice as much time for two of these jigs.
Yeah.
And, but you're a very good person and said, I agreed to this, and here is where we will stay.
Yeah, exactly. So I got the epoxy to stick together. Things were not blowing up. The way that I locate jigs was I harassed Techno, the company that made the machine that I was using, into giving me a drawing of their table. So that's the actual grid of the table of the Techno. And then I used a stare at edge finder to find the distance from the Z0, X0, and Y0 to the corner of the phenolic of the table. And then I just locked that sucker into place. And this is kind of the file that I would start from for everything. But to locate it, they never intended this grid to be used for location, but I use it for location. So I would put these acetyl pins into the slots of the jig and bump them up against it. And they would bump up against these squares and everything would be located correctly. So that way I could just put the jig in the same spot every single time and everything would be good. Now, here we can see what I'm talking about with these slots. So I drew these hot dog shapes and I machined these hot dog shapes into the jig. So that way, those holes that I was machining into that flat surface of the back of that neck, they could index off of that. So I couldn't twist this neck if I tried, because the pins were stuck into these slots. You can also see I put these are 5/8 circles that I just blasted through the jig. And the reason that I did that is when you're using a CNC, CNCs don't like corners. So I just blasted holes through this so that way there was a relief area for the volute as well as the point of the heel, but then everything else makes contact. You can see in this top view all of the vacuum sections. So there was one vacuum slat down here at the heel and one vacuum slat on the center section, as well as one for the peg head. And I also excluded the tuner holes. So I put vacuum foam where the tuner holes are. So when I cut those in, I wouldn't lose suction. And then we also, and let me turn off the table again so you can see. I also put it around the peg head. So
to me, these were all parts of this process that I never even would have thought about. So like having Tom's input was amazing. Like I knew that the neck needed to be held in a position, but I didn't know what would go into the engineering underneath it.
Yeah. So then I found the shape of the swoop of the peg head as well as the fretboard side of it. And I made this surface. And this was actually what got machined. So the machine would come in and it would just go all the way across. Because if I just tried to use this one section, the machine would only go up to those edges and it would leave a little bit of a round around the edges of the peg head, which we didn't want. Because then when I flip it over, then that could lead to suction problems. So I needed to make sure that I was machining absolutely every part of the headstock clean. So then when I put it back to carbon on the other side, it would be okay. And then the final tricky thing is if we look at this block right here. I wonder if I have it. Yeah, there it is. So here is that shape that I machined on the back of the neck. I put that on there as well. And then this corner right here is where the neck would bump up against some pins that were machined into the jig.
Mm-hmm.
And this is how I oriented the neck along the y-axis. So we have these pins holding that are fixed in holes in the neck that are aligning it on the x-axis. So it can only move forward and back along the y, and then I would scoot the neck up until just that tip was touching, and then we're good to go. And that worked fantastic. And then also the machine would come in and cut out the peg head at this point. And then finally, after all that was done, should be, is it this one? No, it's not this one. Face down jig, face template, neck jig, healer, neck redraw, face down. Where is it? Ah, there it is. And then finally, the neck would be machined on the back, and we would machine in the carve. So to do that, I made a jig that had the a little ramp for the face of the peg head, which also had some vacuum, so that way I can suck down the face of the peg head. I used some really high-tech material called packing tape to tape the back of the peg head once the tuner holes were drilled, because otherwise I would lose suction through that. Packing tape works great. So that sealed my tuner holes, so that way I wasn't having any issues there breaking the vacuum. And then these surfaces are kind of interesting. We can look at the jig, which you can see it has a ball end mill. It has a slot for the ball end mill on both sides, so that way when my ball end mill was going back and forth, it wasn't like destroying the jig and then deflecting into the neck, because I needed the ball end mill to actually go past this surface and underneath it, because otherwise you would get those flares. So when you're working with the ball end mill, the tip of your bit is going to be a ball, hence why it's called a ball end mill. And so I use a 5/8 bit. So that means that 312.5 thou of the tip of my bit is going to be round before I get to a flat edge. And I needed that flat edge to go all the way across. So I made these relief cuts for that to happen. Also, the other cool thing about this is that the floor of this jig is radiused for Trevor's compound radius on his fretboard. So you can see that that's radiused as well. There are vacuum slats. And then what I did was I needed a way to locate the neck onto this jig. And at this point, I couldn't go start drilling holes into things because this was going to be a final product. So the locating holes for this jig are actually below the fret markers on Trevor's fretboard. So I put holes where the fret dots would be in the jig, and I put those in the fretboard. So then after Trevor got the neck, he could go and he could take his inlays and inlay them into the inlay pocket, and those holes would be hidden underneath the inlay pocket. But two of the fretboards didn't have 12 fret markers, so I had to exclude the 12th fret for that. But the jig is made so that you can locate the entire neck off of the fret markers from any position. So there's holes for all of them, depending on what I needed. So that would locate everything X, Y, Z. And what these surfaces here are for are, again, I don't want the ball and mill stopping right at the profile of the neck or of the head, the peg head. It's going to leave a little swoop up. So I made these kind of, they're sacrificial surfaces, and it's a little bit, it's probably like 80 thou above the surface of it. So one, the machine wouldn't touch the back of the peg head that I already machined. And two, this would allow me to have this bit travel past this wrist area and down. So that way we would have the most complete machining possible. So that's the whole process. That was every step that I did. And those were all the little tricks that I used in order to make things move smoothly and get things as accurate as I could. The other thing that I had to work around was that there was going to be this guy sticking out, and I couldn't machine that off. So I had to kind of do some fancy footwork to have the machine machine this before I started machining things, and then these edges got machined, but it left out this back area, so that way I wasn't chopping off the spoke nut. But yeah, that's the whole process.
Yeah, that had always been a big, like, what about the truss rod? Like, how do you get that end? So if you do it first,
Yeah,
and the fretboard is cut the same, the fretboard and the end of the neck heel are aligned perfectly.
Yep.
And you can glue it up and never even touch the end of the heel again.
Yep, exactly.
Cool. So what do you
I
think?
actually haven't seen all of this yet, like with the green surfaces and whatnot. So it's pretty awesome, Tom.
Have you gotten a neck produced with this?
Yeah, we did 4, and I'm spraying the first one now.
It was also sent roasted maple, which I found out is the messiest wood to machine. I don't know what it is about roasted maple, but it produces so much more mess. Like, I was doing one neck and I was like, how is this entire machine room like, it looks like a hurricane went off in here. So I'd clean it up, do the next one, and it was like just as much of a mess. So I don't know what it is about roasted wood, but it makes a huge mess.
Interesting.
Yeah, it's basically coming
Yeah.
off in individual chips versus creating dust or potentially like fibers that would stay somewhat together.
Yeah.
Yeah. I would imagine it's a little more like a hardwood. Like, does rosewood cut that way?
No, because rosewood is so oily, it like powders. Rosewood, cocobolo, lignum vitae. If you guys have ever heard of lignum vitae, they are like the nicest wood to machine for like a finish. Like the finish off of those woods is like perfect. Ebony ends up being the chippiest, obviously. So there's some like tricks you have to use to kind of avoid the splits. But when it comes to doing like mahogany versus regular maple, they kind of machine the same way. Mahogany, you have to, or I'm sorry, maple, you have to be careful because it likes to burn, just like with any router. But the roasted stuff, like, yeah, it made like almost like papery chips, and they were like very statically charged. So if you tried to like pick it up with a dustpan, it would like fly everywhere because the static would like send it flying. It was wild.
Yeah, I know that there will be a couple of edits in the future, but hopefully things that wouldn't affect all of the jigs.
Yeah.
Maybe just a single one, like the radius of the fretboard, or something like that.
Mm-hmm.
But for the time being, I mean, if I have to align, I will have to come up with my own alignment system for the jigs. But once that is established, then I can be milling these.
Yeah.
And I mean that's really amazing.
Yeah.
I assume we could even mill a surface that matches the Techno surface, right? We could mill that in MDF first or something.
Yeah.
So yeah, I mean,
Even if
like
you took
part of this. Go ahead, John.
So even if you just made, you put 4 holes that aligned with the holes in the bottom of the jig, that would do it even without the whole grid having to be there. Because I was only using one portion of the grid anyways.
Cool. Yeah. The milling on the necks brought us to a point that I could hit the surface with 120, and I did a little bit of orbital work but mostly handwork, and it was about an hour. So it'd be like kind of the amount of work I would do regardless. Um, if I had carved in this neck, it would have been at 80 grit, and I would have had to move through 120, 220, 320. So
Yep.
that was cool.
Hell yeah.
And the like you had said about that milling on the back transition of the wrist where those transitions happen,
Mm-hmm.
like that stuff really got within that point of like I just took a block and
Yeah.
did a little bit more blending. And that was wild because the first time you sent me a drawing, it was like, okay, it's just going to end here, and you're going to
Yeah.
have to go over the spindle and just kiss it, But
Yeah, I remember that day. I was like, I can send it, because I was like so gun shy of messing with the jigs because I had the 2 blow up, and I was like, please Lord, just like everything's working. Like I don't want to touch this jig. And then I was like, I can totally make this work. I'm just gonna have to nut up. And like I did. And it worked, which is great. Which is why you don't see in the drawing where those relief cuts were, because those relief cuts were just made from the machining of the actual neck.
right. So the first time the machine hits the jig, it makes the mark, and that mark
Yes,
is you're never going to go any deeper than that.
exactly. Yeah.
Yeah,
Yeah.
that's cool. I mean, that sort of stuff uh, around like trusting that tool to just like go into the jig that you'd spend hours
I know.
creating was like,
Yeah, like
yeah,
after having all the stuff blow up, I was like, I really don't want to. Like it works. But like
yeah,
I'm so like it's just like a few more passes. And like I could totally make this work. And then I was like, I'm just gonna risk it. I was like, and so that's why when in that drawing you see, let me share this again. But you can see this green surface right here, as well as this one over here. Let me hide the jig. So these surfaces are there so that the bit would stop before, like if the bit tried to do this, it would stop at this surface, but this would allow the bit to get well below the face of the peg head to do those wrist areas. So you can see the gap underneath the peg head. And
that's
this
crazy.
allowed me to do that.
Yeah, dude, it's magic.
Really
A
cool.
lot of thinking. It was a lot of thinking.
You enjoy thinking?
I guess. So and I'm gonna make a confession. All of the ideas that I came up with for this, like any of the jigs or the fixturing that I end up making, I think of in the shower in the morning.
Mm-hmm. How does that make you feel, Trevor? So,
Dirty.
yeah. Okay. Good.
Yeah.
Um.
But I mean, I appreciate that. Like, I'll be
Uh,
riding my bike into work or something and be like, I know exactly what to do now. It's when
Yeah.
you're not like in it.
yeah. The walk.
Or like when you had asked me about like some of the headstock repairs on the last time we talked, it was just like, dude, I just had to cut it in that moment. Like if I'd walked away, my process would have been gone from my brain. If I had to take a photo, I wouldn't have remembered. It was just like, oh, I get it. Walk to the saw, cut. It's sort of like the idea of plunging that bit into the jig. It was just like, nope, you just do it. But like with Tom, it's the knowledge of that surface being below the jig that allows the bit to travel down. Like I don't know the machines like that. I don't know the technology. So that's really cool.
Cool. All right. Well, I think I'm gonna stop it here.